Hello, guys. I'm back here to help you out, and today we are going to talk about dilations. So, here we go. For our warm up today, we are going to review another type of transformation. Okay, so on your paper or your notebook, just like yesterday, please write the title here for us, warm up. So then we know which one we're doing and what we're talking about. You do not need to copy the picture, okay? But let's read what they want us to do. Triangle ABC was transformed to create triangle A prime B prime C prime. Well, I didn't even need this sentence because I know that the original letters A, B, C, D, E, F, they are the pre-image, right? The original shape. And then A prime, B prime, C prime, that is the image, the new one, right? The one that was created from the original one. So I already knew it was going like in this direction, that it was going from here to there. But okay, the sentence is up there to help me understand that even better. Here's the question. Which rule best describes this transformation? First of all, we have four types of transformation. So far, we have studied three. Okay, so I know it's one of those three. The first one we did was translation, when we simply slide a shape. The second one, reflection, the mirror one, right? And the third one, rotation, when we turn. What is happening to this triangle? Well, it's not being rotated because it's not sideways or upside down or anything like that. It's not being reflected. It's not a mirror because otherwise the A that's on top was going to be all the way on the bottom, right? They were supposed to be like a butterfly type of thing or a bow tie or something. And that's not what we have. The only thing that happened is I grabbed that triangle and I slid down. I brought it down, right? So we're talking about translation. That first one. Translation is when we add or subtract depending on the direction we're going. So here we go. I noticed that my shape is not going right or left at all. It's staying in the same like position. It's just sliding down, right? So over here, I can on your notes, you can write not right, and you can also write not left. Okay, because it's not moving to the right or to the left. Now it is moving down. I know that for sure, right? So it is moving down. But how much is it moving down? That's when we count the units. That's when we count the little squares in our grid. So let's start. I don't know. I will pick point A. You can pick whatever point you prefer. So from this point A to this point A, how much is it moving? So let me see. 1, 2, 3, 4, 5, 6, 7, right? It's moving 7 units down. So let me write this over here on your notes, please. 7 down. It's moving 7 units down. So let's put these words into math terms. Well, if the x is not moving, if it's not going right or left, the x is going to be the same, right? So my original x and y, that is going to become, well, x is still the same thing. That doesn't change because it's not moving right or left. Now the y is changing. If it's going down, my y is changing. And then it's changing. I'm losing amount. I'm losing numbers. I'm losing quantity because when I go down, it's minus, it's negative. Now, how much is it going down? It's going down 7. That's it. That's my answer. Which letter says that? F, right? I believe it's letter F. So letter F over here has the correct rule for this transformation. Does that make sense? I hope this rang a bell on your head, and then we can continue from here. All right, so let me clear that and see what is next. Quick write. So here we go. On your paper, please put the title Quick Write or on your notebook. And here's what I would like you to write today. In your own words, describe what you noticed between the two toy vehicles. So, what is the same and what is different? So, please pause this video and write your ideas on your paper, and then you press play again when you're ready to continue. All right, I hope you did that. Okay, I hope you noticed that the colors are the same. Let me write a few ideas over here, right? So colors are the same. What else? The shape of the object is the same, right? So the shape is the same in the sense of it's not like one of them it's a teeny tiny car looking thing and the other one it's like a transformer monster truck type of shape, right? They are the same shape of car, right? But what is different now? Well, I bet some of you said the one on the right it's bigger, the one on the left is smaller, which I can summarize that the size is different, right? But you can write like the one on the right is bigger, or one is bigger, the other one is smaller. That's fine. It says in your own words. So hopefully you used your own words. But this is dilation. This is what we're going to talk about for the next few minutes that I'm recording this for you. When we talk about dilation, the colors can change or they can stay the same. The most important thing is that the shape is the same, the format is the same. So the angles don't change, but the length of the sides, the size of that shape, that's going to be different. Okay, it's going to grow or shrink. Hold on, I'm getting ahead of myself. One thing at a time. Here we go. Let's take some notes. So here's the thing. First thing that I would like you to have on your paper is actually the title, dilation, so you know what we're going to talk about the whole class. Okay, so you can write something like, today I learned about dilation. Okay, or you can put something like title, dilation. You can pick whatever you prefer. Okay, or you can write dilation really big and underline or something like that, just so you know that this is where your notes will start for the dilation topic. All right. Next thing that I want you to write, vocabulary, please. Vocabulary. We have like 3 terms that are very, very, very important for our lesson today. So go ahead and put vocabulary. Okay. And here is the first one, the super, super important word, enlarge. Now, what does enlarge mean? Do you think it means growing or shrinking? Getting bigger or getting smaller? Well, if you see the second part of the word, it says enlarge. It's getting larger. It's getting bigger. So this means growing, right? To enlarge, it means to grow. But if you prefer, you can also write bigger, like it's getting bigger. It's okay. Whatever works for you, whatever you prefer, you can write both as well. Always good. Now, the next word, super, super important, to reduce. Hopefully, you know that this is actually the opposite of enlarge, right? If I reduce how many minutes of class we have, that's less minutes. If I reduce how much money you get, that's less money, right? Reduce means to shrink or to get smaller. Okay, so let me write shrink or smaller. Sounds good? Up until here, are we okay? All right, guys, remember at any point during this lesson, if you get confused, if you don't understand, if you have a question, pause the video, write on your paper, put a question mark, or write, I didn't understand this, I didn't understand that, and you can always come and ask us. Okay? Next term over here for our vocabulary, scale factor. Scale factor. Please write that on your paper. Extremely important word. In dilation, scale factor is the number that we use to multiply, okay, our numbers on the coordinate grid. Now, here's the thing, because in dilation, we only multiply. This is the good news too. Remember translation, the very first one we learned when we did, if it's up, it's positive. If it's down, it's negative. If it's right, it's positive. If it's left, it's negative, right? We were adding and subtracting. Now, in dilation, there's no adding or subtracting, okay? It's only multiplication. Sounds good? And that number that we use to multiply gets a special name because it's so special since we only multiply. So it's called scale factor. So I'm just going to write over here like number we multiply, because this scale factor is the fancy name for the number that we multiply when we're talking about dilations. Okay, if you have a better way of explaining that to yourself, because the notes are for you to reference back. Okay, when we take a quiz, I believe this Friday we have a quiz. Okay, when we take a quiz, you can use your notes, right? So you can look at this paper and hopefully it's going to make sense to you, not to me. I know the stuff, I'm good, right? But your notes need to make sense to you. Okay, so this is the number we multiply. In our formula, this number will be represented by the letter K. All right. So if I were you, just a suggestion, I would put the letter K over there close to scale factor and number we multiply. So we remember that that K is our scale factor. Is that all right? Up until here, are we good? We have a few more notes. I'm going to have to clear that. Okay. So we can go to the next part. Next part, I want to give you the formula we are going to use. So please write that on your notes. The formula we are going to use is if you have an X and a Y, then it means that we're going to have to multiply by the scale factor. So kx, ky. Every time that there are no symbols between two letters or a number and the letter, it means that they are multiplying, right? So for example, 7x, that means 7 times x, right? If I say, I don't know, 5 over 7y, this means 5 over 7 times y. Whenever there are no symbols between a number and a letter, that means multiplication. Okay, so this is the formula for dilation. Okay, and then I'm going to rewrite that later on. But this is very important that you have on your paper. Now, let me give you two examples. The first example, it's going to be an enlarge example. Let's do one at a time. Okay, so first example here, enlarge. Okay, draw on your paper, and I know we don't draw a lot of things a lot, but for this one, it's going to be very useful. Draw like a teeny tiny triangle on your paper and put the letter A inside, just so we remember that this is triangle A. Let me see over here. Let me a little lower so we can read a little better. Okay, this is my triangle A. All right. I'm going to make up numbers over here because since it's just an example, I want this side to measure 4. I want this side to measure 3, and this one here to measure 5. Okay, so put that there. And now we're going to draw a bigger triangle, okay, because this triangle went through a dilation. So bigger triangle over here, hopefully a similar shape, right? Not a super weird triangle, just the same triangle, but bigger, okay? And please call this triangle A prime because that's my new triangle, right? So A prime. Sounds good? Now, let me put some numbers over here. This side over here, let me see, 8. This side over here, maybe 6. And this side over here, 10. All right. What do you notice about that? What happened from my original triangle to my new triangle? What happened to those sides? Well, first of all, we know it's growing. This is an enlarge example, right? An enlargement example. So I know it's growing, right? For sure. So that means my scale factor is going to be positive. It's going, well, it's always going to be positive. It's going to be more than 1. But then again, I'll come back to that later. I am getting ahead of myself. Hold on, one thing at a time. Let's write the formula for how did, if I can only use multiplication, how did 4 become 8? How did 3 become 6? How did 5 become 10? Well, all of them were multiplied by 2, right? So this is how we write it. So again, on your notes, please write scale factor, scale factor, lower, scale factor, it looks crooked, scale factor 2, right? And as a formula, it's going to look like I had my original X and Y, and now those were changed into 2X, 2Y, because they were multiplied by 2. You see what I mean? That's it. This is dilation. Is that okay? Is this example all right? I believe I'm done with this example. I'm going to give you now an example for a reduction. Whenever I shrink a shape, because again, this one is growing, right? I want one to shrink now. So let me clear all that. And now let me give you an example for one that reduces. So let me give you a reduction example. On your paper, please write reduce and draw, I don't know, let's see, let's change it to a square. Draw a square, like a big, big square. Mine is not going to be super perfect, but I'm trying my best. I'm sure that you are trying your best as well. Let's call this square B. No prime because this is my original square, right? Now draw a smaller square. This one is looking more like a rectangle. Let me see if I can fix it. All right, inside the square, please type b prime, or please write b prime. Oh, not a lowercase b, right? I picked a, there we go. B prime. Right, that's my new square. All right, let me put some numbers over here for us, some values over here for us. Please do the same. Put them on your paper as well. Hopefully you are copying that on your notes. Let's say that this over here, the sides are 12. I don't need to write in all of them because if it's a square, all the sides are equal, but okay, okay, okay. And let's say that the teeny tiny one is 6, right? So 6 over here, 6 over here, 6 over here, 6 over here. Okay. Awesome, guys. So again, this is my original one. This is my new one, right? Because B and B prime. How only using multiplication, and this is a little tricky now. Only using multiplication. How does 12 become 6? I bet a lot of you thought dividing by 2, and then you're like, but we can't divide, we can only multiply. You see the challenge, right? So let's think about that. Do you guys agree that multiplying by half is the same as dividing by 2? Hopefully you do. Hopefully you understand that. So what I can say is that my scale factor is half, 0.5. Or, of course, I can use it as a fraction as well, right? And then I can write, let me write it like this so my fraction looks like that. So it doesn't have to be tilted. 1 over 2. You see what I mean? So the scale factor can be as a decimal or as a fraction. Okay, so the scale factor is 0.5 or 1 over 2 because I'm multiplying by half. Is that okay? Let's see how that will look if I actually have the formula, right? So I had an original x and y, and now I have a 0.5x and a 0.5y. Does that make sense? Always multiplication. Okay, we don't do division, but we can multiply by a decimal, which makes it smaller, right? A decimal less than 1. And then again, I'll come back to that and I'll emphasize this point in just a little bit. Now, some problems, they will not give you the option of a decimal, right? Because a lot of the questions are multiple choice. So you might see something like xy transformed into, oh, and let me try to make this a little prettier for you guys over here. 1 over 2 x, comma, 1 over 2 y. My y, little y. You see what I mean? Those two options are exactly the same thing. One is using a decimal, the other one is using a fraction, but both of them mean half, right? So that's it. That's dilation, right? That's reducing, okay, using a dilation. Guys, always multiplication, okay? So now here we go. Here's the thing. Let me write a few extra things, a few other things we need to know about dilation, okay? So before we move on, the first thing is that, write that on your papers, please. In dilation, we only multiply. In dilation, we only multiply. We never add, we never subtract. And when you feel like dividing, multiply that by a decimal or by a fraction, okay? But it's always multiplication. Now, I do have good news, okay? Because this number that we are multiplying, well, first of all, it's always the same number. Always the same number. Okay, so this is very good news. It's not like you have to find a number for the x and a number for the y. If it's 0.5x, it's also going to be 0.5y. If it's 7x, it's also going to be 7y. You see what I mean? It's always going to be the same number. They can never be different. If it's different, your dilation, it like failed, or that's not a dilation, it's not correct. Okay, the numbers always have to be equal. They always have to be the same. All right. Another piece of good news, the number is always positive. Always positive. Always positive. It's never going to be something like negative 3x, negative 3y. That's not okay. That doesn't happen in dilation, okay? So the number is always, always positive. All right. What else do I want you to remember? Okay, so about the scale factor. So what I mentioned before, if the scale factor, the one that is represented by the k, right? If this number is bigger than 1, scale factor bigger than 1, right? This means that my picture, that my shape is growing, is being enlarged, okay? This means enlargement. Does that make sense? Every time it's bigger than 1, it means it's growing, or you can write growing as well if you prefer. Write both because the word enlargement is used a lot. I want you to get used to both. And the last thing that I want you guys to remember, it's the opposite of that. So if the scale factor, or my k, right, is less than 1, that means it's reducing. I'm talking about a reduction. I have to reduce my shape, okay? So it's shrinking. Is that okay? Yes, maybe, not sure, a little confusing. Guys, it's actually relatively simple. So we are going to do a few example problems over here so you can see what I mean by bigger than 1, less than 1, enlarging, growing, reducing, shrinking, scale factor, k, always positive, same number. It's a lot of information at once for notes, but once we get to the problems, everything is going to make more sense. So let's get to it. Here we go. These are for our notes on your paper, right? With your notes, you are going to simply write the x, y is changing. It's not writing. Why not? Let's go. X, y changing into kx, ky. Okay, this is what your formula for dilation will look like. There are no tables, there's nothing more to memorize, like that's it. Okay, if you want to put the extra information here, always like k, k bigger than 1 means enlarge, and then k less than 1, oh, I put a capital K, that's okay. It means to reduce. Right? You can put this information as well if you would like to keep that handy for yourself. But here we go. Let's get to a few examples. Look at this one here. So on your paper, please put the title, We Do Number 1. Okay, I'm going to do this one with you so you understand what I'm talking about. Determine which of the following geometric transformations represent dilations. So I'm giving you a bunch of transformations here. I want to know which one is dilation, which one is not dilation, which one is right, which one is wrong. Okay, for dilation, of course. Look at the first one here. So I have xy transforming into 0.4x, 0.4y. My first question for you, is 0.4 multiplying x? Is 0.4 multiplying y? Meaning, are they multiplying? Is this a multiplication? Yes, it is. Remember when I told you just a few minutes ago, if there are no symbols between a number and a letter, that means they are multiplying. Right? So the 0.4 is multiplying the x, it is multiplying the y. Perfect, multiplication. My second question, is it the same number? 0.4, 0.4. Yes, it is. That's dilation. All right, so please put this one here on your paper. Copy this one here on your paper because this is a dilation. Okay, so far on your paper for this problem, I need we do number 1, and then you copy that first one, x, y, arrow, 0.4x, 0.4y. All right, let's check the next one out. Xy transforms into x plus 3, y plus 3. My first question, is it multiplying? No, it's not multiplying. X plus 3. In dilation, I cannot add and I cannot subtract. I cannot do anything but multiplication. So this one is wrong. I'm already going to cancel it over here. Let me cross it out maybe in red. Right? I'm going to cross this one out. Do not copy this one on your paper. Okay? This one is wrong. Let's check the next one here. XY transforming into 12x 4y. All right. First question. Are they multiplying? Is this multiplication? 12x? Yes, that's multiplication. No symbols between the number and the letter. multiplication. 4y, yes, that's multiplication. No symbols between the number and the letter, multiplication. Beautiful, it is multiplying, yes. Second question, is it the same number? 12, 4. Not the same number, not dilation. Cancel this one. Do not copy this one on your paper. This one is wrong. If one is 12, the other one is 4, that's not dilation. For dilation, they have to be the same number. Look at the first one again, how beautiful. 0.4, 0.4. They're both multiplying and they are the same number. That's dilation. Is that okay? Let's try the next one here. xy transformed into x minus 2, y minus 2. Are they multiplying? No, they're not. This is wrong. Do not copy that on your notes. This is not dilation. Let's check the next one. xy, 1 over 3x, 1 over 3y. Is this multiplication? Yes, it is. It's multiplying a fraction, but it's okay. It's multiplying, right? Beautiful. So yes, it's multiplying. Next question. Is it the same number? Is it the same fraction? 1 over 3, 1 over 3. Yes, it is. Perfect. They are multiplying and it is the same number. Fantastic. In blue over here, we'll come back to my blue. Please copy that on your notes. This is dilation. This is what dilation looks like. Let's try the last one. xy transforms into 2x, 2y. Is this multiplication? Yes. Is it the same number? Yes. Copy that on your notes as well. And then again, if I'm going too fast, it's as simple as pause the video, you copy and then you press play again. Sounds good? Here we go. Next slide. We do number 2. On your paper, go ahead and please write the title. We do number 2. We do 2. Okay, and here's the next one. Which rule best represents the dilation that was applied to quadrilateral FGHJ to create the quadrilateral F prime, G prime, H prime, J prime? Okay, I didn't even need a sentence, or I could only have the question, which rule best represents the dilation? Because you guys are supposed to know which one is the original and which one is the new one. Guys, look at the one inside. Look at the trapezoid inside, the teeny tiny one. Do you see the normal alphabet letters F, G, H, J, right? And now look at the one outside, F prime, G prime, H prime, J prime, right? That's the new one. So from the original to the new one, growing or shrinking? From the one inside, right, the pre-image, to the image, to the one outside, the one with the prime, growing or shrinking? Guys, it's growing. It's getting bigger, right? So please write that on your paper. We do number 2, grow. This one is growing. All right, when it's growing, I need my scale factor to be more than 1. So write that on your paper as well. Our K needs to be more than 1. I'm looking for a number that it's multiplying, but that it's bigger than 1. All right, so here we go. Well, let me ask my same questions again, just like we did on the previous slide. Okay, letter F, 5 over 7x, 5 over 7y. Is it multiplying? Yes. Is it the same number? Yes. Keep it there. Let's try G. X plus 1, y plus 2. Is it multiplying? No, it's not multiplying. So I know that G is wrong. Let me cancel out G over here. I know that G is already wrong. I don't have to think about the numbers. I don't have to think about anything else. I know G is wrong for sure, because in dilation I cannot add. All right. All right, let's try H. 1.4x, 1.4y. Is it multiplying? Yes. Is it the same number? Yes. Keep H over there. Let's try J. X minus 2, y plus 1. Is it multiplying? No. J is already wrong. Guys, just by remembering that dilation has to be multiplication, you can eliminate 2 options. Look how beautiful. I love those dilation problems. This, by the way, is a STAR test question. Okay, I'm from either last year or like 3 years ago, something like that. All right. But here we go. Now I'm between 2. I need my dilation, my scale factor, to be a number greater than 1, because I already recognize that it's growing. So which one of those is more than 1? 5 over 7 or 1.4? I'm sure you know that 1.4 is bigger than 1. So you probably know already which one is the correct answer. However, if you are stuck in that 5 over 7 and you're like, I don't know if 5 over 7 is bigger than 1, where can you go? Decimals. So here we go. Let me show you. Let me open my decimals. Let me show you. Here's my decimals. Go ahead and type 5 over 7. And then you have your number as a decimal, easier to recognize if it's bigger than 1 or not. 0.714 something. 0 point whatever. Bigger or smaller than 1? Smaller, right? 0 point something smaller than 1. So it cannot be the 5.7 because it has to be the other one. It has to be growing. So we come back here and we know that our answer has to be H. On your paper, please don't write just the letter H. I do not want a random H on your paper, right? Write H, X, Y, arrow, 1.4X, comma, 1.4Y, close parentheses. Sounds good? Let's go to the next one. I bet you guys are doing amazing. We do number 3. Please put this title on your paper. We do number 3. This one here is a little different than the other one. We're going to have to write a little more, okay? Take a deep breath, be patient, stretch your back on your chair like this. Now the other side, and crack your fingers, go like this, oh, beautiful. Determine which of the rules represent enlargements and which of the rules represent reductions. Guys, here's the thing. Those are all correct dilations. I already know that they are all multiplying and that they're all the same number. This has been done for me. What I have to do now, what we have to do now, we have to figure out who's growing and who's shrinking. Which ones are more than 1? Which ones are less than 1? Enlargement, reduction. Is that okay? We're going to go one at a time. So on your paper, go ahead and call this first one here A. And then the next one there, call it B. And please copy those on your paper. I know it's like my students today were like, oh my miss, this is a lot. This is writing a lot. Oh, for crying out loud, it's not an essay, right? So like I said, crack your fingers, be patient, okay? And go ahead and copy those on your paper, please. This is very, very, very good practice, okay? So E, F. Here we go. And I will help you with that. Again, if you need more time to copy, please pause the video, copy, and then continue over here. Letter A. It says 0.4x, 0.4y. 0.4, bigger than 1 or smaller than 1? 0 point whatever, smaller than 1, right? If 0.4 is smaller than 1, this is a reduction. We can write reduce because it's getting smaller. It's shrinking. Is that okay? Yes? Let's try B. 1.1. 1.1 is more than 1 or less than 1? Greater than 1 or less than 1? 1.1 is more than 1, right? If it's more than 1, it's growing. Growing is called enlargement or to enlarge. So please write enlarge for letter B. Let's try C. 5 over 6 x, 5 over 6y. If you don't know, just by looking at the fraction, if it's bigger than 1 or smaller than 1, you can always go to decimals, right? So let's go to decimals. Let me show you how. If you already know, beautiful, great, write on your paper. But if you don't, let me show you on decimals. 5 over 6, right? Let me open my decimals here. 5 over 6. There it is. As a decimal. In my brain, it's a lot easier to look at a decimal, so I may use decimals more. If you can look at a fraction and you know, that's fine too. 0.8333, 0 point whatever, bigger or smaller than 1? 0 point something, always smaller than 1, right? So back to the notes. If 5 over 6 is 0 point something, this means it's shrinking. It's getting smaller. We call it reduce. It's reducing. It's a reduction. All right, next one, 0.9999. Again, 0 point something, 0 point whatever, 0 point, even if it's 99999, right? 0 point is less than 1, okay? So 0 point something, reduce as well. This one is also getting smaller. Next one, 10. Guys, 10, more than 1 or less than 1? What do you prefer, $10 or $1? If I told you I'm going to give you a grade, do you prefer a 10? Do you prefer a 1? Right? So 10 is bigger. 10 is more than 1. If 10 is more than 1, this is an enlargement. This is growing, right? So enlarge. This is getting bigger. And the last one here, 0.001. 0 point whatever, right? Every time it's 0 point something, that's less than 1. So this is a reduction. So you can write reduce. I hope that made sense. I hope that was okay. I hope the last three you could do completely on your own without even needing me over here. So let's keep moving. We do number 4. Please write that on your notes. We do number 4. Keep that on your notebook. Remember, you guys can use your notes right during your quiz on Friday. Circle 1 was dilated with the origin as the center of dilation to create circle 2. Guys, if circle 1 was dilated to create circle 2, which one is the original? Because in this problem, we don't have the regular letters and then the prime letters. But look at the sentence on top, right? Circle 1 was dilated to create circle 2. Do you see, do you understand that circle 1 is the original shape, was my first shape, right? And then now I have circle 2. Something happened to my circle 1 that now I have circle 2. What happened? Did it grow or shrink? Did it get bigger or smaller? It got bigger, of course. Look at circle 1, really teeny tiny. And now look at circle 2, so much bigger. So go ahead on your paper. After you write we do 4, please write grow. This one is also growing. Every time that it grows, it means that our scale factor has to be greater than 1. Our number that multiplies has to be greater than 1. All right, let's check our options. First of all, let's try to eliminate, right? So we don't have to think about every single one individual one. So letter F, 3 over 8x, 3 over 8y. Is it multiplying? Yes. Is it the same number? Yes. Keep it over there. Letter G, 8 over 3x, 8 over 3y. Is it multiplying? Yes. Is it the same number? Yes. Keep it over there. We're going to think about it later. Letter H, x plus 5, y plus 5. Is it multiplying? No. I already know that it's not H, right? I already know H is wrong. Let me try J. X minus 5, y minus 5. Is it multiplying? No, it's not. If it's not multiplying, I know it's not J. Cancel J. Then again, just by knowing the dilation, we can only multiply, right? Then we get to cancel half of those. Now, I realize that it's growing, so my scale factor has to be more than 1. Which one of those, F or G, has the number multiplying the x and the y that it's bigger than 1? If you cannot look at the fraction and recognize it like that, it's okay. Take a deep breath. Where can you go? What can help you? Desmos can. Here we go. 3 over 8, 8 over 3, right? Which one is bigger than 1? That's what I'm looking for. Desmos. 3 over 8. And what was the other one? 8 over 3? Which one of those is bigger than 1? 8 over 3. Because 0.375, that's less than 1. 0 point something, less than 1. And 2.666, 2 point something, 2 is more than 1, right? So 8 over 3, that is our scale factor. That is the correct scale factor for this problem. This is the one that's growing, right? So on your paper, go ahead and please write G, but don't write only G. Write the whole entire X, Y arrow, and then 8 over 3X, 8 over 3Y. Is that okay? Is dilation making a bit more sense? Are things fitting a little better in our heads? I bet it is, right? I trust you guys. So here we go. We do number 5. I have this quadrilateral ABCD that was dilated with the origin as the center of dilation to create the quadrilateral A prime, B prime, C prime, D prime. I didn't even need the sentence there, but okay, I have the picture. I can tell that the one inside is the original, the one outside is new. So if this is what I had and this is what I have now, it's growing. It's growing again. So here we go. On your paper, guys, we do number 5, and please write grow. If it's growing, I need my scale factor to be more than 1. Oh my gosh, I need a few shrinking examples over here. This is getting too easy. All right. Which rule best represents the dilation that was applied to quadrilateral ABCD to create A prime, B prime, C prime, D prime? Okay. What is the correct dilation, right? This is what they're asking. So here we go. Letter A. Is it multiplying? Yes. Is it the same number? Yes. Keep it over there. Letter B. Is it multiplying? No, it's not. It says x plus 3. That's not multiplication. I know it's not B. Letter C, 2.5x, 2.5y. Is it multiplying? Yes. Is it the same number? Yes. Keep it over there. Letter D, x minus 1.5, y plus 3. Is it multiplying? No, it's not. Cancel D. Now we're only between two. Look how beautiful. Because I know it's growing, I know my scale factor has to be more than 1. Which one is more than 1? 0.4 or 2.5? Well, 2.5 is more than 1, right? If I tell you I'm going to give you $1, what is better than $1? 40 cents or $2.50? Well, $2.50. That's so much better, right? So this is the one that makes it grow. Please copy that on your paper. You do number 1. This is the first one that I want you to try on your own. So I'm not going to give you the answer for this one. Okay, on your paper, please write you do number 1. Pause this problem. Look at the picture. You don't even need the sentence on top. You can look at the letters, you can look at the drawing, and you can see which one is the original, which one is the new one, right? So look at the picture, look at the image, and then tell me which rule is the correct rule for this dilation, right? Remember to ask yourself, is it multiplying? Is it the same number? Okay. Does it have to be bigger than 1, smaller than 1, growing or shrinking? So which one is doing that? All right. Go ahead, pause the video, give it a try. All right, guys, so here we go. We do number 6. On your paper, please write we do number 6. This problem is a little different, so I'm going to help you out with it, okay? It says square WXYZ is graphed with vertices at W, -2, 2, X2, 2, Y2, -2. Okay, I don't need you to write this whole entire paragraph on your notebook, okay? But I do want you to write those points. So go ahead and write W. W is -2, 2. Okay, please write that on your notebook. Write X, Y, and Z as well. I'm going to put them over here. So X, 2, 2. Y, 2, -2. Please don't abandon your negatives. Be careful with that. And Z. Oh, I forgot to put them as capital letters. It's okay. Do you guys forgive me? I hope you do. Alrighty, guys. So I have our points over here. Hopefully you have that on your notebook or your paper as well. Now let me keep reading. If square WXYZ is dilated by a scale factor of 5, very important term. Remember I told you when we talked about vocabulary in the beginning, very, very important term, scale factor of 5. What are the coordinates of the new vertices of W prime, X prime, Y prime, Z prime? I want to know which ones are the new points. Okay, that's what I'm trying to find out. Remember, dilation is only multiplication, is the only thing we can do with dilations is multiply. Guys, I'm going to multiply all these numbers by my scale factor, by 5. Here we go. As easy as it sounds. Maybe it doesn't sound as easy. I think it's easier than it sounds. W prime. Well, W was -2, 2. Guys, how much is -2 times 5? If you don't know, go to decimals. But that is -10. Now, for the second number there, how much is 2 times 5? 10. I'm all done with my W prime. That's it. That's all I have to do. The scale factor is the same for all of them, the X and the Y and all of the points, right? So I'm going to apply the same scale factor in this problem, 5, and I'm going to multiply to all of the numbers that I have there, all right? So let's try the X prime. X prime over here. 2, 2. Okay, guys, how much is 2 times 5? 10. And the other 2, how much is 2 times 5? 10. That's it. That is my X prime. Let's try the Y prime. Y prime. 2. 2 times 5? 10. -2. -2 times 5? -10. right? Be careful with your negatives. Don't abandon your negatives. If you feel like you're not very good with negatives, go to Desmos. Desmos is very good with negatives. As long as you type them in there, Desmos will help you out. Now, Z prime, I have negative 2. Negative 2 times 5, negative 10. The other one is also negative 2. Negative 2 times 5, negative 10 again as well. Guys, these are my new points for my new square. W prime, X prime, Y prime, Z prime. I hope that made sense. And here we go. We're going to go to the next one. This is a you do. You do number 2. This is the second problem I want you to answer on your own because it's exactly like the one we just did. It's exactly like this one over here. Okay, but I would like you to try it on your own. So on your paper, go ahead and please write you do 2. And then only write the points. Remember, I don't need you to write this whole entire paragraph. Okay, but please write A, 0, 1. And then you write on your paper as well, B, 5, 1. And then please write C, 0, 4. I want you to find A prime, B prime, and C prime. Okay, and I am telling you here that the shape was dilated by 2. Guys, we're not multiplying by 5 anymore, right? 5 was the old problem. This is a new problem. Now it's being dilated by 2, by a scale factor of 2. So now you are going to multiply all these numbers by how much? You can do it on your own. I have faith in you. Let's do another one together. Hopefully you did great on your you do number 2. On your paper, please write we do 7. And here we go. Look at this problem. Triangle ABC was dilated to form triangle A prime, B prime, C prime. Okay, so the purple one over here, the big one on the right, is my original one. And that generated the A prime, B prime, C prime, the blue one, the tiny one on the left, the lower left. Okay, so my first question for you, growing or shrinking? If my original is the purple and my new one, right, it changed into the blue one from the A to the A prime. Okay, so is it growing or shrinking? It's getting smaller, right? So this one is shrinking. Go ahead on your paper, please write reduce, because this one is not growing. This one is reducing. This is a reduction, okay, to reduce. All right, so if point A is located at 2, 6, and A prime is 1, 3, what is the scale factor? Guys, now I'm asking you, okay, it's reducing, it's getting smaller. By how much? Is it getting just smaller like, just a teeny tiny bit? Or is it getting smaller like, really like microscopic, or somewhere in between? Right? How much smaller is this getting? This is my question. Okay, I'm asking for the scale factor. So let's think about that. How does 2 become 1? How does 6 become 3? Maybe your heads went back to dividing, right? Because it's getting smaller. But remember, we have to use like either decimals or fractions, okay? I bet you were thinking, divide by 2, right? Very good. That is correct. But how do we divide by 2 using multiplication? Remember, divide by 2 is the same as multiply by half, right? So here we go. What is the scale factor? You can answer that in 2 ways. You can say 1 over 2, or you can say 0.5. I will accept both. Both are perfectly correct, okay? If this was a multiple choice question, you could see A, 1 over 2, B, 1 over 3, something like that, okay? Different fractions, or you could see decimals. So you pick how you want to answer. If you want to write both, so you remember it's the same thing, that's a great idea. That's a fantastic idea. All right, here we go. We do number 8. Triangle ABC, the tiny one, you see the bottom one on the left, right? The smaller one was dilated to create an enlarged triangle A prime, B prime, C prime. Okay, they're pretty much giving us all the answers, right? They're telling which one is the original, which one is new one, and telling us that it's growing, enlarged. Okay, so what is the question? What do they want if pretty much all my answers are there? If point C is located at 3, 6, and point C prime is located at 9, 18, oh, what is the scale factor? It wants to know, okay, it is dilation. and it is growing. It is enlargement. It is, right, getting bigger. How much is it getting bigger though? By how much? These numbers on A, B, and C, they were multiplied by how much? Right? Multiplied by 1.5, multiplied by 2, by 3, by 4, by 7, by 100, by 1,000, by 1,000,000. I don't know. Right? We have to check it out. Now, so here's my question to you. How does 3 become 9? How does 6 become 18? Multiplied by 3. Exactly. Hopefully you got that right. So go ahead and write that your scale factor, scale, I can spell. Let's try again. Scale factor is 3. You can also write something like k equals 3. Remember, the scale factor is represented by the letter k, right? Very good. You can also write like this: 3x, 3y, right? Using like the formula way, all right? Does that make sense? Again, guys, I would recommend writing all three, because if this shows up in a quiz and it's a multiple choice question, maybe you will see like the first one with the word scale factor, maybe you're going to see with the letter K, maybe you're going to see like the formula 3k, 3x, and 3y. All right, so I would recommend writing all of them. You do number 3. This is the third problem today that I would like you to try on your own. All right, so on your paper, please write you do 3. My question is, what is the scale factor used to create the triangle P prime, Q prime, R prime? So look at the picture. Okay, look at the P, R, Q. Find a point in there. Where is R? Or maybe if you pick P, that's fine. Where is P? Find that location, right? And then where is the P prime? Where is the Y, the R prime? Or maybe you prefer to work with Q. That's fine. Find the location of Q. Find the location of Q prime. Does that make sense? Now, let me pause over here for just a second and show you another way to do that. What you can also do is look at your original shape. And if you have straight sides, sides that follow the grid, not diagonal sides, right? If you have like horizontal or vertical sides, what you can also do, you can count those units. So you can go like 1, 2. 2 turned into how much? 1, 2, 3, 4, 5, 6. 2 turned into 6. That means I'm multiplying by how much? This is my question. Okay, this is scale factor. This is what I want you to tell me. Okay, I'm gonna start talking. Was supposed to be a you do. I pretty much gave you the answer. We do number 9. A quadrilateral ABCD is graphed. There you go. Our quadrilateral, a trapezoid. If the shape is dilated by a scale factor of 2, okay, I'm gonna make this trapezoid dilate by a scale factor of 2. 2 is more than 1, so I know it's growing. Ha! What are the new points for A prime, B prime, C prime, D prime? Well, so for this one, I'm going to need over here my original points first, right? So what is A? A is located at 1, 4. So 1, 4. B. B is located at 5, 4. 5, 4. Please put that on your paper. Please copy that. Letter C. C is located at 4, 1. Letter D. Here we go. Last one for my quadrilateral. 2, 1. All right. Scale factor of 2. Guys, it means that I am multiplying all these numbers by 2. And then I am going to figure out my A prime. So here we go. And all of the other one prime. So A prime. 1 times 2, 2. 4 times 2, 8. That's it. A prime is done. I'm ready for B prime. Guys, how easy is that? I think dilation is one of the easiest ones. I really like dilation. I don't know. I like it. I like multiplying. I don't have to think about up and down and right and left and x and y and positive and negative. It's all multiplication. It's all the same number, right? Here, beautiful. Here we go. B prime. 5. What, am I multiplying by what? 2. 5 times 2, 10. 4 times 2, 8. Let's try C prime. C prime. 4 times 2, 8. 1 times 2, 2. Last one, D prime. 2 times 2, 4. 1 times 2, 2. That's it. Those are my answers. These are the locations of my new points. I hope this is making more and more and more sense. I hope it's getting easier and easier and easier. You do number 4. I want you to try this one on your own. So please write on your paper. You do number 4. You do not have to copy the shape, right? But please write on your paper if it's growing or shrinking. Read the sentence up there. Don't be lazy, right? Check out which one is the original, which one is the new one. Is it growing? Is it shrinking? K more than 1 or K less than 1, right? Scale factor bigger than 1 or less than 1. And then which rule follows that? Right? Is it multiplying? Is it the same number, bigger than 1, less than 1? Now, this one, you also have to check it's growing by how much. It's kind of two questions in one. It's a bit of a challenge, but I'm sure you guys can do it. Okay, you can count the little squares as well if you prefer, like I did. Okay, counting like the base with the other base, or like the top with the top, something like that. And that's it. This is dilation. Okay, this was our lesson for today. I hope it made sense. And you also have a DOL. Very, very, very short DOL. Okay, only one question if I'm not mistaken. So go ahead and practice that DOL for today. Guys, I hope this is helping. So then, whenever your teacher gets here, which is really, really soon, then you guys will be like pretty much on track with the other classes as well. I love you very much. Thank you for working hard. I really appreciate you. And if you guys ever want to stay for tutorials or you want extra help or something like that, please come talk to me. My room is 212 right down the hallway. Please come talk to me. I am always here to help you. Bye. I love you. Have a great afternoon.